Hi friends, how are you? This is our favorite channel, Physics Gallery, Ashavi. Okay, today we are going to the fourth lecture of our electric charges and electric field. Our fourth lecture. And today we are going to discuss certain numerical problems from our topic Coulomb's law, last topic Coulomb's law. And the first question is given in the board. You have to read it. Two identical copper metallic spheres. Two identical copper metallic spheres, A and B, having equal charges Q, each are kept in air, experiences a force F. That is, there are two identical metallic, that is copper spheres or metallic spheres, A and B, having the same charge Q, are kept at a distance R in air. Some distance they are kept in air, experiences a force, and they experiences a force F. We have assumed the distance as R. 1 by 4 pi epsilon 0 Q into Q square by R square. This will be the value of that force also. Okay. Now what happens? Another identical copper sphere C. We have taken another identical copper spheres C, but uncharged. It is not charged. Is first brought in contact with A. It is brought in contact with A. There is C. C is first brought in contact with A, then with B, and is removed. Find the new force between A and B. After this process, is there any change in the force F? Earlier force? Or so if there is a change, what is the new force? This is the question. So what is the concept you have to, whether you understood what is the question? Okay, so what is the concept you have to use here? It is that when an uncharged sphere touches a charged sphere, comes in contact, we have studied during electrification by conduction. Okay, so what happens? Charges are shared between A and C. C was initially kept in contact with A. A has a charge Q, C has no charge. But when they are kept in contact, A shares its charge with C by the method of conduction. Since they are identical, the spheres are identical metallic spheres. They are identical. The charges are shared equally. If they are unidentical, the charge sharing is not equally. That topic we will discuss along with capacitors, the second chapter. Okay. Since here the spheres are identical, the charge sharing will be equally when they are kept in contact. So, when C is kept in contact with A, the half charge Q becomes Q by 2 and C gains the remaining Q by 2. The same C is now kept in contact with B. Now C has certain Q by 2 charge and B has Q. So, what is the total charge in the system B and C? 1 by 2 plus 1, 3 by 2 Q. So, B and C have a total charge of 3 by 2 Q, and when they comes in contact, this is equally shared. That is, half of this goes to B, half of this goes to C. So, half of 3 by 2, half of 3 by 2 Q means 3 by 4 Q. That means now C contains 3 by 4 Q and B also contains 3 by 4 Q. Is it clear? During sharing, if the spheres are identical, the charges are shared equally. If they are not identical, they are not shared equally. That will be discussed along with the capacitor, potential and capacitor, the next chapter. Okay. So, the new force F dash becomes 1 by 4 pi epsilon 0. What is the new charge in A? Q by 2. What is the new charge in B? 3 by 4 Q by the same distance R square. So, F dash is equal to, on solving, 1 by 4 pi epsilon 0 Q into Q square by R square, 3, 2 into 4, 8. This value is the force given earlier. So, we can write F dash is equal to 3 by 8 of F. Okay, F dash is equal to 3 by 8 of F. This is the new force. Okay, is it clear? So, this is the first question we have to discuss. Pause it, copy it and solve it. Now, we are going to our second question. In the second question, There also 2-point charges are given. You may write 2-point charges plus 4q and plus q. You may write the question. 2-point charges plus 4q and plus q are kept at a distance a apart. They are kept at a distance a apart in free space. Okay, 2 charges plus 4q and plus q, plus 4q and plus q are kept at a distance a apart. Is it clear? Now, a third point charge. There is a third point charge plus small q. This plus small q is kept in between plus 4q and plus q. Plus q charge is kept in between plus 4q and plus q. The question is find the position of plus q, the new charge, from plus 4q, so that the system remains in equilibrium. This is the question. Okay, so what is the question? What is the position of plus q from plus 4q so that, suppose we are putting this plus q here. Okay, you have to find the position of plus 4q from plus q. Suppose we are taking it to be x, so that the system remains in equilibrium. The system remains in equilibrium. What is equilibrium condition? In the plus 1 topic we have studied the system will be in equilibrium when the net force acting on it becomes 0. The system will be in equilibrium when the net force acting on it becomes 0. That is plus q. Here there is a plus 4q and here there is a plus q. Plus 4q repels plus q towards the right. Plus 4q repels small q towards the right. So the force on plus q due to plus 4q is towards right. This q also repels small q towards the left, repulsion. So force on plus q due to plus capital Q is towards the left. That is, the two forces acting on plus q are opposite in direction. And to make the system in equilibrium, the second condition is the magnitude of force must be equal also. That is, the force acting on plus q due to plus 4q must be equal and opposite to the force due to plus q due to plus capital Q. This is the condition. 1 by 4 pi, now solving, just simply solving. 1 by 4 pi q 4q by what is the distance? X square is equal to 1 by 4 pi epsilon 0, permittivity of free space, into q, capital Q, by what is the remaining distance? The total distance is a, this is x, the remaining is a minus x, the whole square. Solving 1 by 4 pi epsilon 0. Q, capital Q. Then 4 by x square is equal to 1 by a minus x, the whole square. All of them are square values. Taking the square root, 2 by x is equal to 1 by a minus x. Cross multiplying, 2a minus 2x is equal to x. 2a is equal to 3x, or we can write x is equal to 2 by 3 of a. X is equal to, that is, if the charge plus q is kept at a distance 2 by 3 of a from plus 4q, the system will be in equilibrium. In other cases, in other positions, there will be no equilibrium. Okay, condition. This is the second question we have to discuss. Pause it, copy it, solve it. Now we are going to the third question. Third question. In the third question, it is given that there are 4 point charges. Write it. There are 4 point charges. Q1 equal to 2 mu coulomb, Q2 equal to minus 5 mu coulomb, Q3 equal to 2 mu coulomb, and Q4 equal to minus 5 mu coulomb. There are 4 point charges which are placed at the corners of a square ABCD. There is a square A, B, C, D. There is a square ABCD. Okay. So A contains Q1 equal to 2 mu coulomb, B contains Q2 equal to minus 5 mu coulomb, C contains Q3 equal to 2 mu coulomb, and Q4 is equal to minus 5 mu coulomb. Is it clear? The question is, find the net force acting on a 1 mu coulomb charge placed at the center. Placed at the center of the square. The question, if we place a 1 mu coulomb charge, we are placing a 1 mu coulomb charge at the center of the square. That is, this is the center position. Suppose it is O. A 1 mu coulomb charge is placed here. What is the net force acting on this 1 mu coulomb? This is the question. So how to write? This 1 mu coulomb is surrounded with 4 other charges. Force Q1 provides some force to 1. This Q2 also gives some force. Q3 also gives some force. Q4 also gives some force. So, we have studied a property called as principle of superposition, and the principle of superposition states that the net force acting at O is now equal to force on O due to A plus force on O due to B plus force on O due to C plus force on O due to D. Is it clear? So, what about the force? We are taking the force individually. Here, force on O due to A is equal to the magnitude equal to 1 by 4 pi epsilon 0 2 mu into 1 mu by the distance. The distance, suppose the length, side length of the square is 10 meter. It is given that the side length of the square is 10 meter. So we can write 10 meter square, 10 square. The modulus of force on O due to B equal to B 1 by 4 pi epsilon 0 5 mu. Never take minus when we take the force. Never take the minus of charge when we take the force, because minus is indicated from the direction of force. So never take minus of the charge. Minus Q, minus you never put on the magnitude of the force. Into 1 mu coulomb by again 10 square. What about force on C due to, what is force on O due to C now? Force on O due to C, the modulus of force of O due to C is equal to again 1 by 4 pi epsilon 0. C contains a 2 mu coulomb. O contains 1 mu coulomb by the distance is 10 square. And force on O due to D, its modulus equal to 1 by 4 pi epsilon 0. D contains 5 mu coulomb. Never take the negative sign. 1 mu by 10 square. Okay. So these are the magnitude of individual force. So look on the figure. Force on A, force on O due to A, and force on O due to C, OA, OC. Force on O due to A and force on O due to C are of same magnitude. Their magnitude are same. And what about their direction? 2 repels 1 towards this direction. This 2 repels 1 towards this direction. Equal and opposite force, these two forces cancels out. They cancels out. Is it clear? The force exerted by 2 on O and force exerted by this 2 on O are equal and opposite, cancels out. Similarly, the force exerted on O due to B, okay, and force exerted on O due to D are equal and opposite. They also cancels out. Here there is a value. The side length is given as 10 meter. We have taken directly the 10 meter. No, this is the distance x. Okay, how to take the x? X is equal to, this is L by 2. This is also L by 2. So we can write x is equal to root of L by 2 the whole square plus L by 2 the whole square. On solving, you will get x as L by root 2. Okay, so this is 10 by root 2 the whole square. Here also, every distance is x square. We will write it as x square. No need to solve because all of the forces are cancelling. Okay, so we can write the force on A, O due to A is equal and opposite to force on O due to C. Cancels. Force on O due to D is equal and opposite to force on O due to A. Okay, that is, what is the net force now? The net force acting is equal to 0. The net force acting on 1 mu coulomb is equal to 0. Is it clear? Okay. So, principle of superposition states that the net force acting on a charge is always the vector sum. The net force acting on a charge is always the vector sum. Okay. Here the net force becomes 0. The force provided by A on O and C on O, equal and opposite, cancels out. The force provided by B on O and D on O are equal and opposite, cancels out. Is it clear? Okay. And the distance is not direct 10 meter square. The distance is this much distance. This is 10 meter length. So, L by 2 by the Gauss theorem, root of L by 2 the whole square plus L by 2 the whole square. Take x value, provide. Whatever may be, now we don't have to solve it because we know the magnitudes are equal and the direction are opposite. So, the net force is 0. Okay. So, this is the third problem we have to discuss. And suppose in the same question, pause it and copy it. Suppose in the same question, if the position of the charges are changed like this. Okay, I am removing. Oh, I will rub all of the board. So, suppose in the same question, if A contains 2 mu coulomb, B also contains 2 mu coulomb, C contains minus 5 mu coulomb and D contains minus 5 mu coulomb. If this is the position of charge, whether the net force cancels out, never. You have to find it. This is 10 meter length. O having 1 mu coulomb. What about the direction of force provided by 2 repels? So this is the direction of force on O due to A. What about C? This is negative charge. It attracts 1 mu coulomb. So this is the direction of force on O due to C. So the resultant is F1 is equal to force on O due to A plus force on O due to C. Similarly, 2 repels, 1 repels, minus 5 attracts 1. The force will be F2. The resultant of these two forces will be F2. FOB plus FOD. Okay. Have to take the magnitudes. You have to directly add because the direction is same. And the final resultant will be this F, which is equal to root of F1 square plus F2 square plus 2F1 F2 cos This angle is 90. Solving, you will get a value. Do it in your home. We will provide the answer in the next class. Is it clear? You have to do it in your home and we will provide the answer in next class. Therefore, okay, see you. This is your favorite channel, Physics Gallery, and I am your favorite teacher, Asha Venu. Okay, winding up today's class.